Good afternoon. So today we are going to be looking at Newton's second law and uh, kind of compiling some data that's already been collected and sort of analyzing it to see if we can understand Newton's second law. So in the lab, the first thing that you're going to do obviously is put in your name as usual. And then the second thing that we're going to be looking at is our research questions. And for our research questions, we're going to be looking at how an unbalanced force affects acceleration. And if we think back to the warm up question that was up there, where you're pushing an empty cart versus a full cart. Now, most of us realize that that will lead to different accelerations based on the PhET lab that you guys did the other day. And so the lighter cart is going to accelerate faster. So when we're trying to test out forces versus accelerations, we want to make sure that we're holding mass constant because we already know that mass is going to affect things. And so we don't want mass to have an effect here. And so we just want to be looking at the forces and the accelerations. So we need to make sure that mass is one of our controls, that mass stays the same. This lab is going to be a little different than the others for a couple of different reasons. One of the reasons is that we're going to kind of be doing two labs at once. We're going to be looking at two different things. So the first thing we're going to be looking at is that part A, how the unbalanced force affects acceleration. And then the second part is we want to look at how mass affects acceleration. And again, this time we have to hold force constant because we already know that if we change the force, right, it's going to be changing the acceleration. So we don't want to be messing around with that if we're looking for the relationship between mass and acceleration. The next thing you're going to be working on is your hypothesis. And again, we've got two parts to it. Again, that first part is where we're comparing the acceleration and the force. And so you want to make sure that you label the axes correctly. You also want to draw in what pattern you think it's going to be. So of the four patterns, right, do you think it's going to be horizontal, proportional, inversely proportional, quadratic? Whatever you think, you would go ahead and draw it up. And again, since it's not in words, it's oftentimes a little bit harder for me to get started with something like this. The way that I do it is I just move from left to right. So as the force increases, what do I think is going to happen to the acceleration? Do I think it's going to increase? Then I would draw a line going up. Do I think it's going to decrease? Then I would draw a line going down. Stay the same, draw a line going across. So again, I still kind of think about it in terms of the words and in terms of moving across the graph and think about what's happening. So this one is, of course, acceleration and force, the relationship between them. For research question B, we're going to be looking at acceleration and mass. Again, we would draw what we think the relationship is going to be, and don't forget to include the labels for your graph. The next thing that comes up is a kind of an interesting series of pictures. And what we're trying to do is we're trying to understand what the sort of total force, also called the net force, or the sum of the forces. And really all that's looking at is just adding up the forces on the person. So in this case, we've got these two forces. This is the first situation. And we've got an upward force from the plate and a downward force from gravity. And the trick is to find the net force or total force, we just add up these forces. In this case, they're about the same length, so they would cancel each other out because they're in opposite directions. And that leads us to just having 0 for the total force. If the up is longer, then we would have some little bit left over pointed up. If the down is longer, then we would have some little bit pointed down, right? But because they're in opposite directions, we're just kind of subtracting them. and just kind of seeing if there's anything left over after subtracting. So you'll fill this in the system analysis diagram, the sort of part 2 section. Just double click, open that up, drag the symbols to where they go. The first one, for example, is going to be 0. So you'd be able to just drag that 0 to the dot on the person, and then drag the appropriate arrows to the rest of the people. The next thing we're going to be looking at is the data table. And this is the second reason why this lab is going to be a little bit different than labs we've done in the past. And that's because a lot of times in real life, you would have a lot of data that's already been collected, that's already been sort of analyzed for other reasons. And we want to take that data that's already been collected and we want to use it for our own purposes, right? Repurpose it in a way. So we've added in a couple of extra sort of sections that we're going to need to code so that we can get the information that we actually want from this data table. And the first thing that we're going to be coding is this total force, right? And we already said that total force is kind of adding up all of these forces. So we're just looking at adding up the force of the plate and the force of gravity. And when we're coding this, again, always start with an equal sign and then click on the number that represents the force of the plate, hit plus, and then click on the number that represents the force of gravity. So for that first line, we're just going to have equals, and then we're going to click on the 1200 number. Don't type in 1200. Click on the cell, right? It's F3 that has the cell that we want. And then hit plus, and then click on that negative 500, which is in E3. And that should give us our total. When you hit enter, again, it'll complete the code, and it should show you that you have 700. You can either copy that code down by either selecting them all and doing Control D, or clicking on the little blue dot at the corner and dragging it down. If you get stuck, let me know. The other section that we have to code is the upward acceleration. And again, this equation's a little bit more complicated, but again, it's up on the screen for you. So we always start with the equal sign. And then we have to have parentheses, because what we want is we want the change in velocity divided by time. And so we have to put parentheses so that order of operations does everything correctly. So again, start with your equal sign, put your parentheses, and then select the cell that has the final velocity, the 3.2 in this first line, minus the starting velocity, which is just 0. End your parentheses, hit the slash, which represents the divided by, and then click on the time, which is 0.23 for that first line. And again, make sure that you're clicking on those cells and not typing in the numbers. That way, if the number in the cell changes, the code automatically updates. Hit enter, and you should get your value for that first one. Again, if you guys get stuck, if you have any problems with it, just make sure that you guys let me know and I can help you out. That first one should just be a 14, so it's a good way to just double check to make sure that you did in fact code that correctly. And then don't forget to copy that code down. For research question B, you also have to code for the upward acceleration, but that's it. So do make sure that you guys go in and do the coding for that one. Same equation, right? Final velocity minus starting velocity in parentheses divided by time. Then you are going to have to do 2 graphs, two separate graphs in Desmos, one for question A and one for question B. They do have separate links, so make sure that you guys are using those separate links. It's just going to make things a little bit easier for yourself. And there are a couple of extra things to do for second semester that is worth pointing out when you guys are doing these labs. The first is same thing that you did all last semester, right? Making sure that you're putting in the numbers into the data table, making sure that you're sliding the C slider, removing all the lines that don't fit, writing in your mathematical model, all the usual things, but also a couple of extra things. One being making sure that you're labeling the axes of your graph, right? So one graph is the acceleration and the force. So acceleration will be over on the y-axis, force will be on the x-axis. The other one is acceleration, again on the y-axis, and mass on the x-axis. The way that you guys do that, again, the graph tells you how to do that, but it does say click on the wrench in the upper right corner of the graph. So there's a little wrench that says graph settings. If you click that, there are label spots near the x-axis and the y-axis. So make sure that you guys are putting those in. Don't forget the units. Again, acceleration you can find by sort of looking at the data table that you guys already finished coding on. And it says meter/second/second, or meters per second squared if you prefer, which I do. And then force is in newtons, just capital N is totally fine. And then mass is in kilograms, kg for short. So make sure that you guys are putting in those axes as well. The next thing, and sometimes it's already kind of done for us, but not always, is the error bars. And it's got a symbol that looks like a U that says U horizontal and then U vertical. And that's the vertical and horizontal uncertainty. And so again, you just have to think, okay, what's on the horizontal axis? In the first one, you know, it's force. And so if we can look at the uncertainty for the force on our data table, and it's the part that comes right after the plus or minus. In our case, it's plus or minus 10. So our uncertainty is 10. So we can move that slider over to 10. And that way, when we are putting in those boxes, right, that changes the shape of those uncertainty boxes so that our data can fit better. We'll do the same thing with the vertical. Again, looking at the data table, looking for the plus or minus to tell us what the uncertainty should be for the acceleration. Once you've finished all those things, again, double check it, right, before you close it. Make sure that you're getting somebody else's eyes on it, that you're not missing anything or that you didn't forget anything. And make sure that you take that screenshot and paste it into your lab. And then work on the second graph. When you are ready to write the conclusion, again, it's going to be a little bit weird because we did sort of two labs at once. So you should have a claim for question A and evidence to back it up. And you should have a claim for question B and evidence to back that up. Again, I strongly recommend that you guys go into the classwork tab and class materials of Google Classroom. And there's two things in here that are going to be really, really helpful. One is the conclusion sentence frames, semester 2, and that'll kind of give you guys some ideas on sentence frames and how to word things. And then the second is the lab report self-assessment. And again, that's going to help you guys kind of see if you're missing anything, see if you need to do any changes right before you are done. The rubric, right, with the actual assignment itself is another good place to look, just to make sure that you guys are getting the points that you deserve. when you guys are combining the mathematical models, right, you'll have a mathematical model for A, you'll have a mathematical model for B, and to combine them, what we're going to do is we're going to basically just ignore the numerical part, right? Ignore the C value part. And we're going to stick these two equations together. And what we will end up with is going to be A equals F over M. And if you guys want help working that out, let me know. I can show you guys how to do that. But it's really pretty simple. You just, again, ignore the numerical parts. You'll have A basically equals F, A equals 1 over M, and then we just stick them together. We get A equals F over M. But if you want, let me know. I can walk you through how to do all that stuff. For the prediction force, I know there's a lot of questions that come up about the prediction part of things. You can either use your mass, and the way that you can find your mass is if you just type in your pounds into Google and say, convert to kilograms, it'll convert it to kilograms for you. And then you can just plug into that mathematical model the acceleration of 4.9, your mass, and figure out what force is going to be needed for that. Or if you wanted to and you didn't want to use your own mass, that's totally fine. You can just use the 50 kilogram mass of the jumper from question A. Right? We just stay with a consistent 50 kilogram jumper. You can use that mass, and that's totally fine. Again, don't forget to do all of the parts of the conclusion. Don't forget to check things off and just make sure that you guys are not missing anything as you go through things. Again, the rubric and the self-assessment are going to help with that as well. If you guys have any questions, make sure to let me know. Thanks.